Maintenance of a Linux system. Maintaining your system is essential to keep it running efficiently and effectively. Depending on your computer's use, your maintenance schedule could include tasks like backing up files and checking swap space or removing core files. You can automate some of these tasks with shell scripts, and furthermore, you can use the cron program to make these scripts run at regular intervals. In this nugget, we're going to talk about everything from backing up files to the cron program. So let's get started. Let's start with a discussion of backing up your system. Basically, you have three choices for media. You've got tapes, zip disks or some other kind of removable disk, and compact disks or optical disks. And each of these has its advantages. You just have to decide which is best for your setting. To help you make that decision, I've listed out some trade-offs here, some metrics. We'll talk about which media is best in each of these metrics, and maybe that'll help you make your decision of which backup media to choose for your system. The first thing I've done here is list dollars per gigabyte. So it's just how much money are you going to spend to back up your data. And in this metric, tapes and CDs win out. Zip disks are quite a bit more expensive in terms of dollars per gigabyte. And then I've listed sequential versus random access. Random access is faster in certain situations. Let me draw a comparison to your home audio system. Say you've got a cassette player on your home audio system, and you've got this cassette tape, and you want to play the 5th song on that tape. Okay? Well, to play that 5th song on the cassette tape, you have to fast forward through the first 4 songs to play the 5th song. Whereas your compact disc player in your home audio system, if you want to play the 5th song on the compact disc, you press skip 4 times and press play, and now you're playing the 5th song. Much faster than you were playing the 5th song on the cassette tape. All right, and now back to draw this comparison back to the backup media. You know, if you backed up your stuff on tapes, zips, and CDs, and you need to restore some file, say somebody accidentally deleted a file, and they want it restored. Well, say you backed up a couple thousand files, and the file they want restored was like the 1,000th file that you backed up. Well, to restore that file off of tape, you're going to have to fast forward through the first 999 files to restore that file. And to restore that file from a zip disk or a compact disk, you're just going to go right to that 1,000th file and say restore it, and it's going to restore much faster in that situation. So in that situation, random access is going to really beat sequential access when you're just restoring like one file off of a backup. Okay, and then the last thing I wrote here is just capacity. Just how much stuff can you store on one piece of tape or zip or CD. And tape wins out here. A large tape can store 10 times as much as a CD. But again, you just have to make the decision, which of these metrics is most important to you and which one are you going to choose. I choose to use zip disks because somebody gave me a zip drive for free, so I didn't even have to pay for that. I just paid 10 bucks for a zip disk, and I can use that. So there was no overhead for me, which was important because I didn't want to spend a lot of money on something like a tape drive. And even though it's higher dollars per gigabyte, I'm not backing up lots and lots and lots of data, so it doesn't really matter to me. If you had a job like working for NASA or something, though, zip disks would not be the way to go because the dollars per gigabyte would really start to weigh out because there's so much data you'd be backing up every night. This would just soar through the roof. Okay, so like I said, you have to make the decision that's best for you. And the other thing you have to decide in this whole process is like a backup schedule. Okay, so there's different types of backups that you can do. There's full backups. When you do a full backup, you're backing up everything on the system. Every last piece of data on the system is in the full backup. And these are just like a really time-consuming process. You can't do these every time you do a backup. In a huge installation, a full backup might take like a whole day. So if you spend a whole day doing it, and then as soon as you got done, you did another one. That seems like a waste, right? So you do full backups, every month or every few months or something, depending on your installation. And then in between your full backups, you do incremental and differential backups. Incremental backups are like the daily backups. And when you do an incremental backup, you're doing everything since the last incremental backup. Okay? So you do the incremental backups every day, and then, and they're just going every day. And then when you do the full backup again, then you start your incremental cycle over again. Now the problem here is that if you did the full backup, say you do a full backup once a month, and you do incremental backups every night. Well, just say your disk crashed and it failed on like the 29th day of the month. All right? Well, then to restore your system, you'd have to restore the full backup, and then you'd have to restore 29 incremental backups. All right? And that's a lot of work to do that, to restore your system. So that's where differential backups come in. Differential backups do everything since the last full backup. Okay, so here you're just going to do everything since the last full backup, and so in some sense differential backups are just like a globbing together of incremental backups. Alright, so maybe I'll do a full backup once a month, I'll do a differential backup every week, and then I'll do an incremental backup like every night. Now if my disk crashed on like the 29th day of the cycle, I'd have to restore one full backup, one differential backup, and then maybe a few incremental backups. Okay, so that's much less work than doing like the 29 incrementals and the one full. The differential is saving us quite a bit of work. So that differential backup is just kind of like a medium-sized backup, everything since the last full backup. And you have to plan out your backup schedule. Like I said, it could be once a month for full backups. It could be once every 3 months, once every 6 months. Depends on how sensitive your information is, how much data there is, and you just have to make those decisions for your particular setting. Probably the most standard way to do backups and restores on a Linux system is with the tar command. Tar stands for tape archive. And if you remember back when we were doing packages and installing new software on our computer, we learned tar then. Sometimes we got our new software in the form of a tar file, or what we call a tarball. And we got this file, and it's just like one file, right? But inside of that file is a whole set of files and directory structure and all that. And when we unwrapped that tar file, we got this whole directory structure with files in it, and then we ran some script to install our software. Well, now what we'll do is we'll use tar sort of the reverse way. And we'll use tar to package up our bunch of our files and directory structures and put that into a tar file. Okay, so let me switch over to be the super user here, so that I can actually do this, because you have to be able to read all the different files that you're going to back up onto your tape or zip disk or whatever you got. Okay, so now I'm the super user, so I'm going to use the tar command, and first I'm going to use the tar command to back up some stuff in the long format. Okay, this is sort of the long-winded format, but it's very explanatory, especially for new users. So this is what I'm going to do for you first. Okay, and then we'll do the shorthand next. So the first option I'm going to give to tar is --create, which says create a tar file. When we were installing software, we would use the --extract option because we were extracting files out of that tar file. Okay, so I'll do that. I'll say --verbose, and this just puts it in verbose mode, meaning it'll tell you all the different errors that are coming up, all the files that are getting put into the tar file, and so on. Then I'm going to say same permissions. Okay, and what this does is it just maintains the permissions in the directories that I'm copying over to the tape or the zip disk. And then I'll say --file, which just creates a file as opposed to some awful thing that gets printed out to the screen. Okay, and right here is where you would give your device. Like, so if I had a tape drive, I would say something like /dev/st1 here. I don't have a tape drive, so instead what I'm going to do is I'm going to give the mount point of my zip drive, mount zip, and make a file called tarball1. Now what I would do, if this was a real backup on a regular basis, I would put the date in here somehow so that I can maintain some sort of order, and instead of having all these files on my zip disk, I just maintain this order and saying, okay, this is the backup from this particular day and this particular stuff, okay? And then what you do is you give the directories that you want to back up. So say I just want to back up the home directory and the Etsy directory right now. Okay, so this is what's going to happen, and then this tarball1 file is going to be on my zip disk. Okay, so I'll do this, a bunch of stuff scrolls up the screen. This is all the stuff that it copied in there. And if we go up, let's clear the screen here. Let's go up and look at mount zip. I guess I want to do a long listing there. And you can see the tarball, it's actually kind of big. This is what I wanted to show you. It's an awfully big file, but there's a lot of stuff in the home directory and the Etsy directory. Okay, and so now we've backed up something successfully to an alternative media. Now let me show you the shorthand way to do what we just did before. Okay, let me recall my tar command here. There it is, okay, and I'll just hit Control-C here so I don't do it this time. But now what I'll do is I'll just show you the shorthand format. And the shorthand format basically is all these commands like create, verbose, same permissions, and file, but they all have one-letter abbreviations. So create is C, verbose is V, same permissions is P, and file is F. And so you would do the exact same thing like this. Mount zip, tarball1, /home, followed by /Etsy. And this would do the exact same thing as that other command. And you can see it's a lot less typing. It's kind of cryptic for the new user, CVPF, what's that mean? But for the experienced user, you can decode this and make perfect sense of it and save yourself some time in typing. Now another useful option to the tar command is the verify option. Actually, it's the D option. It's either --diff, you can say, or --compare. And what that'll do is it'll actually do some comparison between what you're backing up and what you're writing to the tape. So if if your tape was just really degraded and bad and in bad shape, then this would catch that and it would say, hey, wait, you're writing this stuff to tape, but that doesn't match what was on the disk, and there's something wrong there. So then you'll know that your backup is not proceeding correctly. Okay, the one letter shorthand for this is D. Okay, for the diff. Okay, and this is and this is useful. You know, don't be alarmed though if you come across some errors when you do this kind of diff or compare, especially if you're backing up directories that are, you know, dynamic, like mail spools or log files or things like that, because they're certainly going to come back with errors, because it's different what you wrote to the tape, and then after you wrote it to the tape, it checks back to the disk, and what's on disk is different, and that's because, you know, some log file has changed, and so it says there's an error there, when the error isn't, you know, really an error. It's just because the log file's been updated since you did the tar. Let me show you an option for the tar command that makes incremental and differential backups really simple. So basically we do the exact same tar command that we did before, like tar cvpf, and then we give the directory or the device that we're going to back it up to, and I'll just call it tarball2 here. And then before we give the directories that we want to actually back up, what we do is we use the ---- newer option, and then we give a date there, okay, like 20th of May 02. Okay, and then we give the directories that we want to back up. So this is going to back up everything from /home and /etc that's been modified since the 20th of May 02. Okay, so that's a nice way to do incremental and differential backups. Now when I hit enter here, a bunch of stuff's going to scroll by on the screen. Maybe you could tell that the amount of stuff that scrolled by was less than when we did the full backup of home and Etsy. Maybe you couldn't tell that. It definitely was. If you scroll back here, you know, there's just not as much stuff in here as there was in the full backup of /home and /Etsy. Another good resource for backups on the net is called linuxbackup.net. I've bookmarked it here. Okay, so it's called linuxbackup.net, and there's good stuff in here. There's example backup commands, there's backup programs and scripts, so there's just ready-made scripts in place that'll do your full backups and differential backups and incremental backups, and you just set the parameters, how often you want them to do it, what you want the files to be named when they're done, and that kind of stuff, and they're just ready-made scripts ready for you to use and do your backups. Now let me show you how to use tar to restore a file from the backup media. So I've got this file linuxsyllabus.txt in my home directory here. I'm just going to remove it. And now you can see that it's gone. And if the user does this and they don't want to recreate the file, they might come to the system administrator and say, hey, can you restore this file from the backup media? And this is very easy for the system administrator to do. Now one note before we do this is that when this file is in my home directory, right, the absolute path name to this file is /home/perry/linuxsyllabus.txt, okay? However, in the tar archive, all leading slashes are always removed. Okay, so this file name becomes home_perry_linuxsyllabus.txt. Okay, the leading slash is gone. So there are no absolute path names in a tar archive. There are only relative path names. So if I'm going to do this restore, I have to be up in the / directory for this to work. Okay, so let me go up to the / directory here, and we'll do this restore. Now the way that you do the restore is you do the tar command, and instead of C for create, we're going to do X for extract, and we're going to do V for verbose, P for same permissions, F for file, and then we give the device or the file that we're extracting from, so mount zip tarball1, okay, and then what we do is we give the directory or the file that we're going to restore, and in this case it's linuxsyllabus.txt. Okay, notice there's no leading slash on the home because the file is not stored in the tar archive with that leading slash, so it wouldn't find it if I put the leading slash on there. Alright, so here's our thing, and I'm going to say enter, and now if I go down into the home Perry directory and do a listing, you'll see that my linuxsyllabus.txt file is now back, and I've restored it from the backup media. Now, if you don't know the name of the file that you want to restore, if you go to the system administrator and you say, I named it syllabus something or other, I don't remember, then the system administrator cannot extract it directly. And instead what you're going to have to do is look through a listing. And then after you look through the listing and get the exact name, then you can do the extract. So let me show you how to look through a listing of a tar archive. So we're going to say tar, and instead of X we say T, or if you're doing the longhand format you would say --list. Okay, now here I say tvpf, and I'll say mount zip tarball1, and I'm going to pipe this through more because it's going to go rolling off the screen if I don't. All right, now I'll do that. I'll hit enter, and now you can start to see the stuff that's in the tar archive. If I hit spacebar, I'll page down through it, and you can see all the different things that are in the tar archive. Once I find the file that I want to restore and I get the exact name, then I can stop looking at the listing, hit Control C, and actually go back to my tar command and say, okay, restore this file now because I know the file name. Another important maintenance task is to keep track of how much swap space and how much main memory or RAM you're using on a regular basis. So let me give you a little review of swap space and how it interacts with main memory, and then we'll talk about how to monitor the use of these two and also how to increase the amount of swap space on your computer. All right, so the swap space, that lives over on your hard disk, and there's some section of the hard disk, it's a partition that is reserved for swap space. And swap space is basically just like a temporary holding place for something that used to be in main memory. Okay, so here's your memory cards over here, and what happens is some process is active, it comes into the system, it's active, and it uses up some of main memory. Then some other process comes in and it uses some of main memory, and some other process comes in and it uses some. And all these processes are active, okay? They're all getting little slices of the CPU over here, and they're all being used. Okay? Now, some new process comes in, and it needs some main memory to operate. Well, the operating system doesn't have any to give it because it's all filled up. So what the operating system does is it sort of determines which one of these is, the most idle. It hasn't been used in the longest amount of time. And it takes that stuff and it writes it out to the swap partition. Now that frees up some main memory so this process can come in and use some of that main memory. Now the stuff that was written out to the swap partition is going to be needed eventually. All right, so that's going to have to come back into main memory eventually, and at that point the operating system will take something else and write that out to the swap space. Okay, so there's this constant fluctuation between what's in main memory and what's in the swap partition, and that just keeps flip-flopping. The stuff that's in main memory is the more active stuff. That's the stuff that is getting slices of the CPU time and being operated on by the CPU, and the stuff that's in the swap partition is less active. It's more idle. Okay, but they definitely, things change from idle back to active and from active to idle, and things just go back and forth from the disk to main memory. Now the question is, how much main memory should you have? How much swap space should you have? And they're hard questions to answer in absolute terms. It depends on what you're doing with your system. But there's a relationship between these two that you should keep in check. So depending on how much main memory you should have that much swap space and then some. How much more just depends on what you're doing in your system. Certainly you should have like 1.2 times as much swap space as main memory. But it's more like 1.5 or 2 times as much. And one thing to note is that depending on your kernel number, if your kernel number is 2.4 point something, those kernels use more main memory or use more memory in general, and so your swap space should be higher on 2.4 kernels than on 2.2 kernels in those previous. Okay, so keep that in mind when you're determining how much swap space to put on your system. Like I said, 1.5 to 2 times as much as main memory. Now let's talk about how to monitor your system's use of RAM and swap space. Okay, so the basic command to do this is the free command. We can use some options with free, but we won't use those right now. We'll just do free by itself. Now there's a few lines here. The first line is the main memory. And this is the total amount of main memory you have, this is how much main memory you're using, and this is how much main memory is free. And you can see by this little chart here that I'm using about 85–90% of my main memory. Now, that seems like an awful lot, but actually this estimate here is a very conservative estimate of how much is free. It's telling you, definitely this much is free, but there's probably a lot more free. And this line down here is a correction of that. Because there are buffers in main memory for things like input-output to your disk and caches and things like that. And those elements, the buffers and the caches, are just assumed to be completely used in this number up here. So all those things are assumed to be completely used. But like I said, this line is sort of a more correct estimate of how much space is free. All right, so somewhere in between these two, closer to this number, is the amount of free space that you actually have in your memory. And then there's this number down here for the swap partition. So this tells you how much swap partition there is, how much is used, and how much is free. And you can see the swap partition on my system is like twice the memory size. Okay, and I'm using a 2.4 kernel, and like I said, for 2.4 kernels you want a swap space that's like twice your main memory size. All right, so this is you know, the basic output of free. This number over here has to do with the kernel numbers, how much shared memory the kernel's using. That's not too much of an issue for us. The main stuff here is this free column and this used column and this total column. Now, if we look at the man page for free, you'll see a couple different options that we can use. There's the -b, -k, and -m options. Use one of those to display the output in bytes, kilobytes, or megabytes. On the last page, the default is just kilobytes. If I don't give anything to the free program, it just displays the output in kilobytes. Then the -o option has to do with that buffer and cache line, okay? And the -o switch disables the output of that display. So if you want to omit that correction, just put the -o option. And then there's the -t option to display totals. The -v option you can see down here just displays the version information. But if we go back up here, the other one that's important is the -s option. And what that does is it does this like continuous run of free. Let me show you how that works. Okay, if I do free with like -s5, for instance, this is going to run free every 5 seconds. Now that might not seem like a big deal, like I could just type free again. It's not that hard to type, right? But the point is, like, you could put this kind of thing in some sort of monitoring script. Like if you were suspecting some program to be consuming memory that runs every night at midnight, well, you can run the little free -s, you know, with 10 or 60 or whatever you want in there to monitor the memory usage when that program starts up to see if it really does eat up memory. That way you don't have to like go into work or go onto your computer at midnight when something runs and check it all out. Okay, so you could just run this into a script, and you can put the output in a file, right, by doing something like free -s5, pipe it into free output or something. Okay, so that would put the output of this command into this file. This file would grow pretty fast if this was something like 5, because every 5 seconds it would add, you know, 4 or 5 lines of text to the file. Something like S of 120 or S of, you know, 240 or something would run every 2 or 4 minutes. Then the output of the size of this file would not be very big comparatively to other things. Okay, so this is how you can monitor the usage on your system. If this number here really was approaching the memory size, and it got up to, you know, 95 to 100% of the memory size, then that's when you would see this number start to grow. All right, this number will always be 0 as long as the amount of main memory that you're using is less than the total that you have. All right, so if you see this number here almost always at or near this number, the total memory usage, you know, if that's at or near the total amount of main memory that you have, then, you know, you should increase your main memory size, because that's just saying you don't have enough main memory on the day-to-day operations. You're always using swap space, and swap space should really be reserved for, you know, very intensive, memory-intensive programs that don't happen regularly on your system. Okay, so that's something you have to decide. If you have the room and you have the money to add main memory, and this number is always approaching this total, then you should add main memory to your system. And you know, the swap space can stay where it is if you add a small amount of main memory. If you like double your main memory, then you should think about increasing the swap space. Okay, and you know, if it's to the point where, you know, the swap space is almost all filled up and you need to increase the swap space just to keep things running, then I'll show you right now a stopgap measure you can take to increase the swap space just to keep things running. And then we'll talk about like a more long-term solution to this. So if you're really running out of swap space to the point that you need to add some just to keep your system running, you're going to add what we call a swap file. Now typically when we talk about swap space, we're talking about swap partitions. Right when we installed our system, we set aside some partition on the disk just to be swap space. And that partition is efficient in transferring stuff back and forth to memory because it's all contiguous. It's all right next to each other. Now the swap file that we create, you know, that's going to be, you know, it could be really big, but it's going to be spread around in different chunks on the disk. And it's not going to be nearly as efficient to transfer stuff to and from memory. All right, but it will be an okay stopgap measure just to keep your system running. But long term, you should be thinking about adding a hard disk to your system with a big fat swap partition on it, and adding some more main memory while you're at it, just to increase the overall memory capacity of your computer. All right, so let me show you how to add a swap file to your system. You got to be the root user to do this, so I'll do that. And now what you're going to do is you're going to create an empty swap file. And the way that you can create an empty swap file is with the dd command. The dd command just basically takes one file and converts it into another file and changes the size and so on. So what I'm going to do here is I'm going to specify an input file for dd of /dev/0. And what this does is the dev0 device is really, it's just some bogus device that outputs zeros. So when I write this to some other file, that file is just going to be empty. It's going to be filled with zeros. All right, and now the output file, I'll specify that, and I'll just put it in the root directory and I'll call it swap file. All right, and now what you do is you give the block size that you want to create. So I'm going to create block size of 1024, which is like 1 kilobyte blocks. And then you give the count of the number of blocks that you want to create. Now, if you're doing this, say you want to add like 256 megabytes of swap space, then this number here would be like 262,154, something like that. If you wanted to add 128 megabytes, it would be half that number. And if you multiply this by this, you'll get 256 megabytes, the number that is 256 megabytes. All right, so I don't want to add this much swap file to my system just because I'm showing you for demonstration purposes. I don't really need it. So instead what I'll do is I'll have a count of 1024. 1024 times 1024 is like 2 to the 20th power, which is like 1 megabyte. Okay, so this is like 1 megabyte of swap space that I'm going to add, and it's going to be in this file called swap file. Okay, now I do that, and it says, this many records in, this many records out. And now what I'm going to do is I need to turn that swap file that I've created in the root directory up there. I'm going to make it active. So I do that by saying make swap /swap file, something like that. Okay, now it says it's set it up, swap version, and it tells you how many bytes it is. And then what you do is you say swap on, and then you say swap file. Now the swap space will be activated. So I do this, let me do the free command again, and you'll see now that the total here is 523,120. It used to be 522 something or other. So what I'll do here now is I'll just say swap off that swap file, and this will make it unactive. Okay, and now let me do a free again, and you can see now that we're back to that 522,104. All right, so this is what happened now. I created the swap file with the dd command. I made it active with the make swap command and the swap on command. And then you could see it increased. It was already effective. And then to turn it off, I said swap off. And now that space is reclaimed, and it will be used for something else on my disk. Now, I just want you to be aware that this swap file that we just created and activated is not going to be active the next time your system boots up, because you're going to have to do the make swap and the swap on commands again to make it active the next time your system boots up. Now, if you want it to automatically be active every time your system boots up because you're going to keep this around for a while, then you need to put an entry in the /etc/fstab file, the file system table file that we looked at when we were talking about the networked file system, NFS. Okay, now you would put an entry in there, and then it would be active every time. You would designate it as a swap file and so on, and it would be active as a swap file every time your system boots up. But really, you should be looking at either buying a new hard disk to increase the amount of partition space that you have, or if your hard disk is really large and you just underestimated how much swap space you would need, then what you can do is you can repartition your disk. And this is a really tricky task, and there's some programs out there, there's some software out there that'll do it. Check on the news groups and find out what people are using right now. The thing I've heard about is Partition Magic. That's a program that you can use to do it. This is certainly a program, if you're going to repartition your hard disk, that's certainly a program that I wouldn't mind spending some money on, because it's a really tricky thing, and you don't want to have all your files get wiped out and stuff. And no matter what, no matter how well respected the program is, if you're going to repartition your disk, do a full backup and get everything saved, so that if everything does kind of crap out on you, then you've got some backup and you can restore all those files and at least come back to where you were. All right, so we've seen the free command that told us about memory usage and swap space usage. The df command is kind of the counterpart to the free command, and we learned about this several videos ago. This command tells you about disk space, how much for each partition, how much disk space there is, how much is used, and how much is available. And then there's this use percentage column over here that's kind of like the quick and dirty percentages of how much is used on each partition. All right, and when you see this number reach 85–90%, then you know it's time to get a new disk. But again, as a stopgap measure, what you can do is go around and delete some unused files. And some really big files that often sit around unused are called core files, C-O-R-E. These core files, also called core dumps, are basically, they're the result of program crashes. And when a program crashes, what happens is a snapshot of memory is taken, and that snapshot is put into this file called a core file. Now, a lot of times, like I said, these things sit around unused, but don't just go around and delete them recklessly, because some people use them to figure out why the program crashed, what line of code it crashed on, what the circumstances in the system are that made it crash. Right? And so they're invaluable pieces of evidence to these people that are trying to track down problems. So don't just go around and delete them recklessly. But if you see them and they haven't been touched or looked at for a while, then what you should do is try and track down who owns it. So look at the ownership by doing like an ls minus l on it. Look at the ownership and see who owns it, and that's who owns the program. The person that owns the core file is the same person that owns the program that crashed. All right? And then the other thing that you can do is use the GDB program. Now the GDB program is a super complicated program. It's the GNU debugger. And this is an invaluable program to people writing like C programs and stuff like that. But as a system administrator, if you're just trying to figure out like what program created this core file, then what you can do is you can run GDB, you can say -c followed by the name of the core file. And then that'll tell you what program created the core file. So maybe it's like owned by root or something because it's some system service. But if you find out what service that is, then you can say, okay, well, Joe is in charge of this service, so I'm going to give him that core file and let him decide whether he wants to look at it. And if he doesn't, then he can delete it. Okay? But you shouldn't go around, like I said, you shouldn't go around and recklessly just delete core files to get disk space back because maybe somebody's using one. So the lesson here is, use GDB, look at the ownership, and pass the core file on to the appropriate party. And if it's not necessary, every time you delete a core file, you're going to gain back, leaps and bounds worth of disk space. So the last thing I want to talk about before we wrap up this nugget is the cron program. If we do a man on cron, you can see that it's a daemon to execute scheduled commands. So it's a daemon, meaning it's always running, but it's in the background, right? And basically cron's like always sleeping. And it wakes up like every minute, and it checks the etc cron tab file to see if it has anything to do that minute. And if it doesn't, then it goes back to sleep, it wakes up a minute later, it checks the etc cron tab file, sees if there's anything to do. If it doesn't, it goes back to sleep, and so on. All right? Now, when there is something for it to do, it executes that program, and then it goes back to sleep, and then that program just runs. Now the programs that cron tab will run will be like, there's no human intervention to these programs. They're just like some command that you run, like, a classic example would be like an incremental backup. You want to do your incremental backup, say, like every night at, 2:30 in the morning, because nobody's using the system then, so you can do it and it won't affect anybody. Right? And that's the perfect time to do it, but you don't want to have to wake up every night at 2 in the morning, log into your system, and do an incremental backup. So that's where the cron program comes in. You just set cron up, you set this etc cron tab file up so that it executes your backup script every night at 2:30 in the morning. And then you're getting work done while, you're home in bed, okay, sleeping. Right? And that's exactly what we want with regularly scheduled events. We want them to run at these regular intervals. We don't want to have to remember to run them or be inconvenienced by running them at these odd hours. All right, so let's look at the format of the etc cron tab file, and then we'll learn how to get commands in there to do what we want to do at the hours and days and weeks that we want to do them. And you can even be more fancy, if you want to say, with the times over here, so that you can do things like different schedules than just hourly, daily, weekly, and monthly. Say I want to do something like 3 times a day. How could I do that? Well, I can do that by using a format like this. I can say 02 for 2 minutes after the hour, and then I could say 4, 12, 20. Okay? And that would do it at 4:02, it would do it at 2 minutes after noon, and it would do it at 8:02. Okay? This is like military time. All right? And then if I said star, 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 that would do it on every day of the month, every month of the year, every day of the week. And it would do it 3 times a day. All right? And that's one extra flexibility. A comma-separated list does it at all those different times. Another thing that I can do is I could say */10. All right? Star, 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 star. What this would do is this would do something every 10 minutes. The slash is like an interval. All right? So this is saying at every 10 minutes on every day of the every hour of the day, every day of the month, every month of the year, and so on, I'm going to run some particular script. All right? So like I said before, the hourly, daily, weekly, monthly, these are just names. And the real indication of how often something runs is over here on the left in the time designations. All right? So if I had */10 in this hourly thing, even though it's called hourly, it would actually run every 10 minutes. Now, if you as a user are going to change, you want to run some particular cron script, you have some backup script that you want to run, or you have something else that you want to run, if you want to run it on this schedule, like daily, you can just go ahead and put that script in the etc cron.daily directory, and then it's going to run at 4:02 every morning. All right, but if there's something that you want to run at some different intervals, say you want to run something on the 15th of every month, or you want to run something at some other interval besides the ones that are listed here, well, you could just follow this format, edit the etc cron tab file, put a new line at the bottom, and follow this format and create a directory called like etc cron.special or something, and then put the scripts in the cron.special directory that you want to run on your special schedule. All right, and it's as easy as that to get the system cron tab updated. You just edit that file, make it say what you want to say, and then put your scripts in the appropriate places. It's time to wrap up another nugget. This was the nugget on maintenance issues. And first we talked about backups. We talked about the different types of media that you could use. We talked about the tar program. We learned how to make a tar file and also how to extract files out of a tar file. And this is probably the way to go, especially if you have your own computer and you're only backing stuff up for yourself. But if you are the system administrator for a network of 100 computers or something big like that, then tar is not going to be the way to go. And instead what you should do is you should check out this program. It's called Amanda. Now, this is an acronym. I know I'm not going to get this perfectly right. It stands for the Advanced Maryland something Network Disk Archive. Okay, and this is this graphical interface that what it will do is, you can do it all graphically, set up what directories on what computers you're going to back up, and it's just one central program that takes care of that. Instead of you having scripts out on all these different machines that you want to back up, it's a much nicer, smoother way to take care of that situation. And then we moved on and talked about monitoring our RAM usage, our swap space usage, how much disk usage we had. And we also talked about how to create a new swap file if you need to do that for some stopgap measure. And finally, we talked about the cron program, which is a way to automate all of these tasks on some daily or weekly basis. Okay, and the cron program can run whatever you want. It can run backup scripts. It could run some monitoring script if you wanted to check out your swap space usage at 2 in the morning. You could have some little script that did that, and cron could run it. All right, and you could check out the results in some log file the next morning. All right, so this is the basics of maintenance issues. We'll touch on maintenance issues and other nuggets for sure. I hope you found this nugget informative, and thanks for viewing.